The world's most important mine has no owner. It's not a hole in the ground. It's a mountain of discarded electronics, growing by 50 million tons every single year. This is the fastest growing waste stream on the planet, and it contains something more valuable than gold: the entire periodic table of metals that make modern civilization possible. We are not running out of copper, cobalt, or lithium. We are throwing them away. The real crisis isn't scarcity. It's a system designed for disposal, not recovery. This is the Energy Historian, uncovering the hidden systems that power civilization. And the story begins not in a remote desert, but in a shipping container in a port in Ghana. Inside that container is a compressed cube of shattered smartphones, laptops, and tablets. It weighs about a ton. If you could magically separate it, you'd recover roughly 300 pounds of copper, 10 pounds of silver, a pound of gold, and a fraction of an ounce of palladium. The value of those raw metals at today's prices is around $15,000. The cost to properly recycle that cube to safely extract those metals without poisoning the local environment is about $20,000. So the container sits. It is shipped from a dock in Europe or North America, labeled as used electronics for refurbishment, and it arrives here. The math is brutally simple. It is cheaper to bury treasure than to retrieve it. This isn't an accident. It's the endpoint of an entire industrial logic. For a century, mining was about concentration. You went where geology had gathered a specific element: copper in Chile, cobalt in the Congo, rare earths in China. You built massive infrastructure to dig and process ore that was 0.5%, 1%, maybe 5% of the thing you wanted. The rest was waste. Today, the highest grade ore for many critical metals isn't in the ground. It's in our cities. A ton of mobile phones contains 100 times more gold than a ton of gold ore. The urban mine is richer than any natural deposit, but we treat it as garbage. The system is perfectly optimized to dig new holes at immense environmental and geopolitical cost, while ignoring the refined, concentrated stockpile sitting in our drawers and landfills. The transition to a new energy system now moves at the speed of mining. But what if the bottleneck isn't extraction? What if it's our refusal to see waste as a resource? Look at the lithium-ion battery in an electric vehicle. By weight, it's about 5% lithium, 15% cobalt and nickel, 20% copper and aluminum. The rest is casing, plastics, and chemistry. When that car reaches the end of its life in 15 years, that battery represents a concentrated lump of geopolitically tense materials. Today, over 95% of these batteries are not recycled. They are stockpiled in warehouses or shredded in processes that recover only the cobalt and nickel, letting the lithium and graphite become toxic dust. The reason is, again, math. It costs more to dismantle and separate the battery safely than the recovered materials are worth. So the system defaults to the cheaper option: mine more. This creates a staggering dependency loop. We build a trillion-dollar energy transition on the promise of circularity, but the economics still point straight back to the dig-and-dump model of the 19th century. Here's where the history of materials crashes into the present. In the 1970s, as electronics began to use gold for circuitry, a secondary market emerged. Urban mining companies would buy circuit boards, burn off the plastics to get to the metals, and use cyanide leaching to capture the gold. It was profitable, and it was horrifyingly toxic. Regulations in the West made the process so expensive that the entire industry did what all difficult industries do: it moved. The circuit boards began to be shipped to places where environmental and labor costs were externalized to informal scrapyards in Ghana, China, and India. The global system bifurcated. The West maintained a clean conscience by exporting its waste. The developing world bore the cost of recovery, often through dangerous, low-tech methods that poisoned land and water. The metal still flowed back into global supply chains, but the true cost was invisible on any balance sheet. This created a perverse incentive that still defines the system today. Because proper recycling is expensive, and because mining gets massive subsidies in the form of land rights, water access, and energy discounts, virgin materials are artificially cheap. Recycled materials must compete with that subsidized baseline, and they almost always lose. So the circular economy remains a theory. The real economy runs on a linear track: extract, manufacture, discard. The entire digital age is built on a one-time use of the planet's most finite elements. Think about that for a second. We took metals that took billions of years to form in supernovas and crustal processes, refined them with immense energy, assembled them into devices with a planned lifespan of 2 years, and then buried them. This isn't consumption, it's geological arson. Now, the pressure is building. The International Energy Agency estimates that to meet global climate targets, demand for lithium will grow over 40 times by 2040. For cobalt and graphite, about 25 times. New mines take 10 to 15 years to permit and build. The timeline for change is set by policy goals for 2030. The math doesn't close. There is only one possible source that can scale fast enough to fill that gap: the urban mine. The stockpile we've already created. Suddenly, the shipping container of junk in Ghana isn't a liability, it's a strategic reserve. The countries and companies that figure out how to tap it profitably will control the next century of industry. The race is no longer just about who owns the best deposits underground, it's about who can mine the past most efficiently. This is the counterintuitive answer to the title's paradox. The mine your phone depends on has no owner because the system is financially engineered to make ownership unprofitable. We designed a world where digging new holes is cheaper than maintaining a library of materials we've already refined. The owner is everyone, and no one diffuse global population discarding electronics, a fragmented network of scrap dealers, and a recycling industry trapped by economics that favor virgin ore. The real leverage point isn't a piece of land, it's a price signal. The moment recycled copper becomes cheaper than mined copper, the entire flow of civilization reverses. The urban mine gets a deed, and that deed will be worth more than any mineral claim. You can see this shift beginning in real time. In 2021, the European Union proposed a law requiring that all new batteries contain a minimum percentage of recycled lithium, cobalt, and nickel. It's a simple, brutal mechanism. If you want to sell here, you must mine the city. China, which for decades was the world's dumping ground for e-waste, has now banned imports of it. Instead, it's building massive, automated recycling complexes to process its own domestic waste stream, aiming to secure its own supply chains. The United States, through the Inflation Reduction Act, is offering tax credits for EVs that use domestically sourced or recycled battery materials. These aren't environmental policies. They are resource security strategies dressed in green. They are nations realizing that the old linear model is a strategic vulnerability. When supply chains stretch across contested oceans and politically unstable regions, the safest mine is the one within your own borders, filled with your own discarded goods. The asymmetry here is profound. For decades, the cost of our clean digital lives was paid by the poorest communities on the planet, who dismantled our waste with their hands and absorbed the toxins. Now, the value of that waste is skyrocketing, and the same communities risk being cut out of the new calculus by automated facilities in industrialized nations. The transfer isn't just between nations, it's between a past of externalized harm and a future of recaptured value. The people who paid the highest price for the linear system may see none of the profit from its circular replacement. So what would it take to actually own the urban mine? It requires reinventing the most basic step: collection. Right now, your old phone is probably in a drawer. That drawer is a tiny locked vault. The cost to persuade you to empty that vault, to transport the phone, to log its components, and to ship it to a facility that can handle it, often exceeds the value inside. The system is paralyzed by millions of tiny, distributed decisions. The solution isn't just better recycling tech, it's logistics. It's creating a network as seamless as trash pickup that treats a dead battery not as garbage, but as an asset that needs to be accounted for and routed. It means designing products from the start not for assembly, but for disassembly. It means making the recovery of materials the primary goal, not an afterthought. The company that cracks that code won't look like a mining company. It will look like Amazon or FedEx, with reverse supply chains as precise as their forward ones. The mechanism is clear. We built a civilization on the flush of cheap energy, which made virgin materials artificially inexpensive. That era is over. The energy cost of mining is rising as ore grades decline. The next system will be built on a different principle, the conservation of energy and matter. In that system, the most powerful entity won't be the one with the biggest digger. It will be the one with the most sophisticated salvage operation. The empires of the future will be built on the ruins of the present. Oh, if you found this useful, consider subscribing. The hidden infrastructure is always there. Now you know where to look.